Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the first analytical application of Bernoulli's theorem, which is Venturimeter. So generally what happens that when the water supply at our home becomes lower, which means that the water amount of water coming in the pipelines of our home becomes lower, then we complain in the water department that the pressure coming in the pipeline is very low. But that which we are calling as pressure is actually not the pressure, is the volume rate flow of water, which means the amount of water or volume of water which is flowing to our house from water department per second. So that is the volume rate flow, and Venturimeter is a device that is used to measure that volume rate flow of liquid. So Venturimeter is used by those hydraulic engineers, or in fact, I will not say them hydraulic engineers. I'll say them the engineers of water department. So those engineers come up with this instrument and they check the rate of flow of volume flowing in the pipes, and if it is lower than the standard levels, then they take the appropriate actions to increase that volume rate flow. But Venturimeter, we are here to discuss the Venturimeter. So Venturimeter is a device which is used to measure the volume rate flow, and we have already discussed in the previous videos that volume rate flow Q is actually dV by dt. Okay, and this is A into V, area of cross section into velocity. Now first of all, let us see that Venturimeter looks like this. There are two cylinders connected to each other, and they are also coaxial and their axis is same, but they are connected one after another, and there are two tubes which are connected with these cylinders. So in JEE, I have seen the such type of questions in which there are four options, and in all those four options this Venturimeter is shown, and in one option the level of liquid in this tube is higher than this tube, in the other option the level of liquid in this tube is higher, in some other option the level of liquid in both the tubes is equal, and in some other option the level they shows that liquid will not rise in these tubes. So obviously let us see the scenario that the cylinder which is having the greater cross sectional area will have the lower velocity. So V1 will be less than V2 because area of this cylinder is greater, and therefore the pressure at this point P1 will be greater than P2, and obviously P1 will be P0 plus H1 rho g. So we can easily predict that H1 will be greater than H2. So in those kind of questions, you should always remember that the cylinder which is having the greater cross-sectional area will have the level of liquid higher in this tube connected to that cylinder. Now we have to find out, in this scenario, we have to find out the volume rate flow also. So let us use the Bernoulli theorem and equation of continuity. So we know that A1 V1 is equal to A2 V2 first of all, and then we are applying the Bernoulli's theorem at this point and this point. So we can say that P1 plus half rho V1 square will be equal to P2 plus half rho V2 square. And obviously I'm not including the H rho g term because these 2 points are situated at same level. So the pressure, the potential head will not be included in this term. So P1 is P1, and P1 minus P2 will be equal to half rho V2 square minus V1 square. Okay, and P1 minus P2 will be H1 minus H2 rho g, and that is equal to half rho V2 square minus V1 square. So cancelling this rho with rho, so V2 square minus V1 square will be equal to 2 into H1 minus H2 g, and let us suppose that H1 minus H2 is H. So V2 square minus V1 square will be equal to 2GH. Now the value of V2 can be substituted by this equation. So let us use a new page. So V2 square minus V1 square is equal to 2GH, and the value of V2 from this equation will be A1 V1 upon A2. So this is A1 V1 upon A2. So this will be V1 square will be common, and this is A1 square upon A2 square minus 1, and this is 2GH. So V1 will be equal to under root of 2GH into A2 square divided by A1 square minus A2 square, and V1 will be equal to A2 under root of 2GH divided by A1 square minus A2 square, and obviously the volume rate flow Q will be equal to A1 V1. So Q will be equal to A1 A2 under root of 2GH divided by A1 square minus A2 square. So this will be the volume rate flow of liquid in the Venturimeter tube, and obviously those engineers are not using and are not deriving this formula at the site, but they have a calculator which has these data already feeded into it, and they just need to find out the value of H, which is the difference of level at the site, and they just put the value of H in this calculator, which uses this formula to find out this value of Q. So if Q is not up to the mark as per the standards, so they increase the water supply from the back end, and if Q is up to the mark as per the standard, they inform the household members that there should be some garbage which is being spotted in the pipeline. So this is the device Venturimeter, which is used to find out the rate of flow of volume in a pipe. In the next video we will be discussing the velocity of flux. Thank you.